Okay, welcome to episode 8. Today we're going to talk about Python operators. So what is an operator? An operator is just simply something like the plus sign here. That is an operator in Python. If we open up the terminal and run 8.py, we see, I need a CD in again. Hello, welcome to episode 8. We are going to cover Python operators. An operator is just simply something like a plus sign, and we'll go over all of the various operators. If we save that, terminal, new terminal, and we cd into this folder, which is Python 7 through 12, and then we can run that, you see that we get the output of 7 because of this operator. So that is a very basic one, and we will be going over them. Python has several different groups of operators. They have arithmetic operators, assignment operators, comparison operators, logical operators, identity operators, membership operators, and bitwise operators. So we're just going to do kind of the 500-foot view of all of the operators really quick. So we'll just run over them. We'll just we'll just do this. So we saw 5 plus 2, which is the addition, of course. We have subtraction, of course. So maybe I'll just run them all together. Let's do that. So all the outputs. We have multiplication. We have division. We have modulus, which I will explain. Basically, you will take a number and divide it by another number and then have a remainder. So this is a good way for odd or evens, and you actually use that quite a bit to figure things out. We have the exponentiation, which is like square rooting if you don't know, and then floor division. So we'll go ahead, save that, run, and we'll see all the different outputs. So obviously 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, 5 divided by 2 is 2.5. If we divide 5 by 2 until we're left with either a 0 or a 1, we have a 1. So it just divides it as many times as it can until there's something remaining. So if this was 4, we would get 0. 5 squared, right? So 5 times 5 to the, like this power, right? Which is 2. So we'll do it again with 3 just to demonstrate. And you see now it's 125. So it just squares this number this many times. And then we have 5 floor division by 2, which is 2. So that's how many times you can divide 5 by 2 if you floor the number. Floor means that you will round down, basically. Okay, so that covers the arithmetic operators. We'll go ahead and just comment this out really quick. Of course. Now we have the Python assignment operators. So you've seen this several times. That's just x equals 5 for this. And then you can do like x plus equals a number like 2. So what this is you're just adding that onto x. So we could actually print x and see what we get. So you see we get 7 because we assign 5 to x and then we add 2. So we plus equals. You'll see this a lot in loops. So we'll increment the loop, and that's how it's finding the index of an element in an array, something like that. So we have that. We also have x minus equals 2. And if we just cut this, paste it down here, you'll see that now we'll end up back with 5 because we start with 5, add 2, minus 2, get 5. We have times equals. So same concept. times equals 2. So now you see that we end up with 10. Because we have 5 times 2, obviously, we have divide equals. So we'll end up back with 5. And you notice it puts it in a float, which is interesting. So keep that in mind. We have the modulus equals. So we can do equals 2. And we end up with that 1 remainder just like we did up here because we're doing 5 modulus 2 right here. And then we have the floor division equals. So we could do this by like 2. We'll just set x to 10 and we'll just actually just comment out all the rest of this stuff really quick. Just so it's a little easier to follow along with. Save. And you see we have 5 because we're just dividing 10 by 2 and we're flooring that response. And we got rid of the floating point number that we were left with the floor divider. So now you see if we do 3 and we're floor dividing, I'm sorry, we're doing the floor division now. We were left with the floating point from the modulus. If we do floor divider of 10, 3, because that gets us up to 9, right? 3 times 3 is 9, and then it just tosses out the remainder. So I think that that's pretty clear. And then we have times equals. So we'll do 2, save. You see it's 100 because 10 times 10 is 100. So then we have and equals. Show you what this one does. Let's do 3, and we'll run that. You see 2. This and equals is the same as the Dunder I and, which if you want to read up on that, you can. It's a bitwise operator, so I don't really want to get into that too deep right now, but just know that it exists. If you ever see it, that's what it is. It's a bitwise operator. Then we have the or equals like this. So we'll do 3. Print that, we get 11. This will just perform an in-place operation between pairs of objects. Like with sets, it does a union operation. Dictionaries, it does an update operation. Counters, it does a union of multi-sets operation. And numbers, it does a bitwise or binary operation. So I don't know that you'll use this in anything that we do in this entire course, but I want you to be aware of things that exist. Other ones you will see possibly are this one. This is the XOR operator. It's another bitwise operator. Again, you can read up on this stuff if you start getting into bitwise things. We have the like right shift and zero fill left shift operators, which are like this, and these are bitwise operators as well. So just be aware if you see any of this stuff and you stumble upon it and you have no idea what it's doing, that it's a bitwise operator, and you can look that stuff up. Okay, now we're going to do comparison operators. So we're just going to use X, we'll set it to 10, Y, and we'll set that to 8 just for demonstration purposes. So you have we have X equals Y that we can do. We can do not equals. So earlier I touched on this barely, but if you do this exclamation point before the equal sign, that is not equaling. So you're looking for a Boolean output if something is not equal. We can do X is greater than Y. We can do X is less than Y. We can do x is less than or equal to y, and we can do x greater than or equal to y. So we'll go ahead and save, run that, and we see that we get false, true, true, false, false, true. So these are all Boolean outputs based on this comparison. So that's pretty useful too. All right, now we're going to get into the logical operators. So in Python, you have and, or not. So for this example, we're going to say, we'll set x again to a value. We'll just use 8, and we can print the output, and we'll do something like x is greater than 5 and x is less than 10. Then we could do something like x is less than 5 or x is less than 10, and we could do print x is something like where we want the we reverse the result and we want it to return false if the result is true. And this one's for the not, so I need to write not, put that inside of parentheses, and then we would have something like x is less than 5, and so we're putting this and statement inside of these parentheses with the not in front of it. X is greater than 10. So we'll save those, print, you see true, true, true. So x is greater than 5 and x is less than 10 because it's 8, so that one's true. This one's true because x is not less than 5, but x is less than 10. And this one, x is less than 5, that's not true, and x is not greater than 10, so both of those are false, but we're using the not, so it converts it to true. So if we were to change these to be truthy, we'll do it with 1. You see that it's still coming out to be true because it is both, right? Like it doesn't meet both of these criteria. And now we'll print it, and you see that it switches to false. So just know that if it meets one of the criteria in and, it's going to get, like in this one, if you have 1, I'll just demonstrate it. So if you say x is less than 5 and x is less than 10, you'll see that it's false now because it's not meeting both of these. So with the and, you have to have a true on both of these, and with the not, it's going to be the opposite, right? So if we have a true to both of these, then this will come back false because we're saying not that, not true. So just remember that the not in front of one of these statements is just saying that it's not happening, right? Okay, next we have Python identity operators, which is and is not. So if we have print x is y, and we have x not in y, and sorry, is not y. Save, run that. We have true and false. So what it's actually checking is to see if both variables are the same object. So if you're using like an object, kind of like we demonstrated object-oriented programming a little bit in I think video 6, it would be referencing the same object, and we'll get into that when we get into object stuff. We also have the ability to do in, so demonstrate that really quick. So we have in, which will return true if a sequence with the specified value is present in the object, and not in, which will return true if it is not present in the object. So for this, we'll use something, we'll make like a list really quick. We'll just assign it to, let's say 1 and 2. And then we will print if 1 is in X. And then we will print if 3 not in X. So these will search the list and see if this is inside of the list. And we'll run those. Both will be true. And then obviously if we do 2 here and we run it again, we get it false because 2 is in there. So that's in. And then we'll just cover the bitwise operators really quick, what they are. And remember, bitwise operators are just used to compare binary numbers. So when we were printing off like the binary of a value earlier, I think that was like video 2 or 3, that's what they would be comparing. So bitwise operators, you have and, you have or, and or is also used in other syntaxes we'll see. You have XOR, which what OR does is sets each bit to 1 if one of 2 bits is 1. XOR sets each bit to 1 if only one of 2 bits is 1. So again, bitwise stuff is pretty complicated for entry level, and you'll get into it. I just want you to know that these symbols exist, and that if you run across them, they're not like magic or witchcraft or anything. They do something very useful. So this is zero fill left shift. We have the not operator here. The double dashes are zero fill left shift, and then we have double right dashes, which is signed right shift. So, geez, I can't type today. So just again, this is just informational. You don't have to practice with these unless you want to. You might use them. They're pretty good for data structure and algorithm stuff, which is way down the road for us. But just know that they exist. It is important to know that.